Okay, so in this video I'm going to go through, well, I guess it's 11F of the Essentials textbook, but there's so much it actually covers, that there's so much theory. I wish I was in class with you to actually go through it. Well, I don't want to lose the class either, so I know that I'm going to go through some of these derivations of where these come from, no doubt, and as I've derived other things for you as well. I'm going to derive these. And look, it's something that I really don't want to do in a video, otherwise it'll take too long. I'd rather spend half an hour in class. And then I'm going to derive these as well. The derivation of these though, these things here, actually come from these identities up here. So what I'm going to do today, just so I can efficiently do it, is I'm going to derive all of these here. I'm going to derive cos of 2u, sine of 2u, and tan of 2u. And they're known as the double angle formulas. Now, I'm going to probably just go through a couple of questions from the text so you guys can get started. But let's have a look at the double angle formulas. Now, first of all, let's do for cos of 2u. Now, considering that our addition formulas, we've got this cos of u plus v is equal to all of this. Let's go ahead and do that. So this is actually, to get to these up here, they're actually easier than you did actually think. So I want you guys to be able to derive those when I get back. That would be nice. Cos of u plus v. Well, if I was to say that we wanted cos of 2u, how could we write that? Cos of 2u, well, we could say that cos of 2u is the same as u plus u, isn't it? Okay, now cos of u plus u, that looks sort of similar. It sort of looks like up here, doesn't it? So if we have, I'm going to use this property here, and instead of replace this v, I'm going to replace it with a u. So what have we got? What have we got? We've got cos of u plus v or cos of u plus u is equal to cos u cos u. We'll do that little brackets there. Cos u minus sine u sine u. Oops. Okay, so that is equal to then, so cos of 2u is equal to cos squared of u minus sine squared of u. Wow, that's what we've got there. So let's have a look. We've got cos of 2u is cos squared minus sine squared. That's pretty easy, isn't it? Now, we looked at last time deriving the formula of, we know that this is, if we look at the unit circle, we know that that's the bloody best circle I've ever done. Okay, so let's, this is 1, 1, -1, -1, and we know that the x-axis, the value or the x-coordinate is cos theta, and we know that the y-coordinate is sine theta. So we know that from the triangle we have cos theta squared plus sine theta squared is equal to, well, what's the radius of this circle? It's 1, isn't it? So sine squared plus cos squared is equal to 1. So therefore, using since sine squared theta plus cos squared theta is equal to 1, therefore let's sub this in. Let's go for cos squared theta, or 1 minus sine squared theta, is equal to, or let's just say that sine squared theta is equal to 1 minus cos squared theta. And let's sub that in to this value here. We've got sine squared minus sine squared u. So we've got cos squared u minus sine squared u. Well, minus sine squared u is minus 1 minus cos squared. Well, no longer looking at theta, we're looking at u now, aren't we? So therefore, we've got cos squared u minus 1 plus cos squared u. So we've got 2 cos squared u minus 1. And wow, that's our second one. So we've just done there. And look, using the fact that cos squared is equal to 1 minus sine squared, we could do the same thing to get this one here. So these are our double angle formulas. And look, to be honest, I could go ahead and ramble and do the same thing. Over here we've got sine of 2u. Well, sine of 2u is equal to the sine of u plus u. And using our addition formula up here, we can say that that's going to be sine of u, cos of u, plus cos of u, sine of u. Okay, oh, well, look, that's going to be sine of u, cos of u, plus sine of u, cos of u. Okay, so that's going to be, we've got, let's take out, so we've got, collect these like terms. We've got sine of u and cos of u. We've got 2 of them, so we've got 2 sine of u, cos of u. Well, there you go, that's that one done. Now with tan, what is tan of 2u? Tan of 2u is equal to, well, it's the sine of 2u over the cos of 2u. Okay, so the sine of tan, so what is the sine of 2u? Well, the sine of 2u is 2 sine u cos u, and the cos of 2u is, well, let's look at, which one are we going to do? Cos squared u minus cos squared u minus sine squared u. Okay, now let's, we could break this up if we wanted to, and I guess from here I could eventually get to, I could get to this. I'm not going to do that today though, because I'm mindful of, I don't want this video to take forever, and I want you guys to actually attempt some problems in class. So this is what I'm going to do. I'm going to get you to just recognize and I guess copy all of those formulas out. That's the first thing I want you to do. So all of these addition formulas and double angle formulas, I can go ahead and prove all of these later on. Okay, I can prove all of these to you later on, but I guess it'll be a bit of a waste of class time without me being there to go through them with you, unless your replacement teacher feels like it. Okay, so up here we've got the double angle formulas. We've proven most of those. Let's go ahead and actually try a few problems. Okay, so at the moment, let's have a look at, we're going to have a look at this one. We want to use an appropriate addition formula to find the exact value of cos 105. Well, let's go ahead and have a go at that one. So let me just get that back. Okay, so cos 105, how do we go ahead and do that? Well, okay, obviously we know the exact values for a number of things, 105 degrees. Now, first of all, let's draw that on the unit circle. Unit circle. Okay, so this is pi on 2 or 90 degrees, and then therefore we got sort of 15 degrees. We got this 15 degrees there. Now, as I've sort of told you, cast. So we know that only sine's positive in this quadrant. So look, the value of this is going to be negative. Let's make sure that we get that right straight away. It's going to be negative. Let's have a look in terms of the triangle. You know, if we've got a triangle here, and look, it's clear from there that this distance here is going to be a lot less distance than here. It's not going to be really, if you think about it, could sort of go out as far as here. So cos it's not going to be a very high value. Like if you get a value close to 1, you're nowhere near it. If you get probably a value even close to a half, you're probably nowhere near it. So let's go ahead, and we've got a visual representation of this. Now how do we do it? Well, first of all, 15 degrees. Let's just consider that we're looking at the first quadrant. The sign of this, if we've got that this is 75 degrees here, okay, because we know that 75 degrees, that means that that leaves 15 degrees in there, and cos of 105 is going to give us that value there. Now let's go ahead and find, so cos of 105 is equal to, well, we know that it's going to be negative in that quadrant, so that's going to be the same as the negative value of cos of 75 degrees. Okay, so that's the first step. Now let's go ahead and work out what this cos of 75 degrees is. Now let's sort of break it up. Cos of 75 degrees, I'm going to sort of do a bit of a side note, is equal to the cos of 45 degrees plus 35 degrees. Now, is this looking a little bit familiar now? This is, let's consider this as u and this as v, and this is actually comes from, well, we've got cos of u plus v, this is our addition formula, is equal to u plus v, cos u cos v, minus sine u sine v. Okay, so is equal to cos u, which is 45, cos v, that's 30 by the way, idiot, cos of 30 minus sine u, minus sine of 45 times sine of 30. Now isn't it pretty cool, because we know the values of these, we know what the values of 45 degrees, 30 degrees, 45 and 30. Okay, now first of all, let's go ahead and do that. Cos of 45 we know is going to be 1 on root 2. Cos of 30, what is cos of 30? Well, we can draw our triangle again, can't we? We draw our 2 by 2 by 2 triangle, cut it in half, which makes that 1, and that's 2. That means that has to be root 3. That is originally 60 degrees, which is pi on 3. This is pi on 6. Okay, so cos of 30 is cos of pi on 6, adjacent over hypotenuse. Oh, that's root 3 on 2. I don't want you to memorize these. Well, I do want you to memorize all the values, but I always want you to consider to go back to that, just to actually practice using your brains. Okay, so that's that, and then we're taking away sine of 45 is also 1 on root 2, and sine of 30 is, well, we've got 1 over 2, which is a half. Okay, so let's do that. We've got root 3 on 2 root 2 minus 1 over 2 root 2. Okay, so we've got the like denominators, so that is equal to root 3 minus 1 over 2 root 2. Now that's for cos of 75 degrees, but remember that we know that cos of 105 degrees is the same as the negative value of cos 75. We've found cos 75, so therefore cos of 105 degrees is equal to negative out the front, or we'll just sort of multiply the sign through 1 minus root 3 over 2 root 2. Work it out in your calculator, but I'm sure the textbook will probably give you an exact value. We want to stay in exact values in specialist maths. So there you go, that's the first question. Now, look, I could go ahead and do a number of these questions, but really, you are just using the formulas, okay? So, and rearranging. Now, when you get down to sort of the end questions, we've got to do some, I guess, proofs using in particular, using the double angle formulas, and we're going to go through some harder questions through year 12. But I'll let sort of that I'll let you get started on those. At the minimum, I'd like you to sort of use the double angle formulas and also the addition formulas to try and find some exact values of sine, cos, tan, cosec, cot, etc. So I'll leave it there, and good luck.